Hi and welcome to today's session on Pythagoras' theorem. So Pythagoras, for those of you who are unaware, he was actually an ancient Greek philosopher who was also a recognised mathematician. Now, arguably, he discovered the Pythagoras theorem, but there are many other evidence out there suggesting that this was actually discovered well before Pythagoras, leaning back to Babylonian times. And also Pythagoras actually ran a group at the time called the Pythagoreans. So arguably maybe one of his followers came up with this, in which case anything that they may have come up with, everything would have got named underneath the leader Pythagoras. So the whole idea of this is working with right angle triangles, where if you've got the two other sides of a right angle triangle, you could always find what the other missing side is. So here we've got our triangle. Here's my triangle with an angle, little right angle here, and I've labelled sides A, B, C. Now the A and B, it doesn't matter which sides you label A and B. For me personally, just because I'm used to working with trigonometry, I always label my side next to my angle as A, because that to me recognises with adjacent. But the longest side is always C. The hypotenuse is always C. So this is the Pythagoras theorem. The idea is C squared equals A squared plus B squared. Now, just to give a little visual behind this, here I've got my right angle triangle, and here I've got squares on the outside of each triangle. So what it's saying is that the area of this has got to be equal to the area of this plus the area of this. But as just stated here, at the moment, C is the subject. C is what we're looking to calculate. In which case, if we had to calculate one of the other two missing sides, so B or A, doesn't matter which, because like I said, it depends on how we've labelled it, we will always subtract the smaller side that we've been given away from the bigger side of the hypotenuse to give us one of the other smaller sides. So let's see this in practice with an example. So here I've got a right angle triangle, and I've been asked to calculate x with one side of 5 centimeters, one side of 12 centimeters. So my hypotenuse is always C. So what I'm looking to do is C squared equals A squared plus B squared, and I've color coded this to try and help follow where numbers are going. So my x squared is going to equal 5 squared plus 12 squared. So that gives me x squared equaling 25 plus 144. So x squared equals 169 once we add these two together. Now I'm looking for the value of x. Obviously at the moment I've got the value of x squared. So to get this, what I'm going to do, I'm going to square root both sides of my equation. Square rooting both sides, x equals 13 centimeters. And that's this solved. Just showing another example where now I'm looking to try and find my length AC. But of course I've been given the length of one of two of my sides, where one of them is my hypotenuse, one of them is the long side. We know it's the long side because it's opposite the right angle. So for this one, it doesn't matter which of these two that we use, but I'm going to use AC squared because that's the side that I'm looking for, equals 8 squared subtract 5 squared. So AC squared equals 65 minus 25, which means that AC squared equals 39. Now again, I'm looking for the value of AC, not AC squared, so I'm going to square root both sides. So square root of 39 to 2 decimal points, because that's what was in my example question, is 6.24 meters. Now of course it's in meters because my other sides are in meters, in which case I'm being consistent with my measurements. Now we can see problems which are a bit more involved. So here I've got a bit more of a harder problem where I've been asked to solve this length of A. Now this actually means I've got to use Pythagoras twice, because first of all I need to solve what B is, which is going to lead me to solve what A is. So B is going to be 18 squared, which is my hypotenuse. Subtract 4 plus 9 squared, because these two added together is going to give me this full length down here, which is, of course, gives me 13. 13 squared is 169. 18 squared is 324. So subtracting these is 155. So B, I could square root both of these sides, but because I'm going to be using B squared, I'm going to literally transfer the 155 straight into this part to work out what A squared is. So A squared is going to equal 155 plus 16, which is my 4 squared, because now I'm just dealing with this right angle triangle here. A squared equals 171, square root in both sides. So A is going to equal 13.08 centimeters to 2 decimal points. And that was just a harder question. So if you like what you see, please subscribe. Thank you very much for watching.